minus 3 e to the negative x is increasing.
So for us to figure out where it's increasing, we have to first find the derivative and then set that equal to 0 to find critical points. So for this one, let's see. We have a product rule. I'm going to rewrite this on the top. It's kind of tiny. It says x squared. Is that right? Minus 3?
Yeah.
And it says e to the negative x. So our product rule is going to be this chunk times this chunk. So to find the derivative, we derive the first one. What's the first chunk derivative? 2x. And I keep the second one as it is. Plus, I keep the first one. And a recall on deriving e to the x is itself times the derivative of the power. What is the derivative of that power? Negative 1. And then we have to see what can I factor out between these two. So looking at the first one and second one, they both have what? So let's factor that one out. And we are going to set them equal to 0. So e to the negative x. And when I put the remaining, we have 2x. If I take a negative out here, then that 2x should also be a negative because 2 negative is a positive. Okay? And then our critical numbers, it'll be x equals negative 1 and then x equals 3. And let's kind of recall what e to the anything is going to be. E to the any power is always positive, no matter what. That is always positive. So therefore, we can't set that equal to 0 and find out the critical numbers on that one. So let's make our number chart. We have negative 1 and 3, and that's for f and f prime. So I need to plug it back in. And when I'm plugging this back in, let's plug it into this form right here. The first number is negative. Second one is e to the x, which means it's always positive. And we'll plug it into x plus 1 and x minus 3. So how many numbers should we be testing? 3. So what number is a good number in the middle? 0. For the other one, you can make it really big. Or right next to it, it doesn't matter. So let's plug in the negative 10. It's going to be negative here no matter what, positive no matter what. When I plug in negative 10 into this function, it's going to give me a negative number. What about the last one?
Negative.
Also a negative. So if I have 3 negative numbers, my result is negative. So we know our graph is going down right here. Now let's plug in the 0. We know we have a negative and a positive no matter what. When I plug in the 0 in here, it's going to give me a positive. Plug in the 0 here, it's going to give me a negative. So we have even number of negatives, so that's going to be what? Positive, so our graph is going up. And then for the 10, we have a negative and a positive. Plug in the 10 into my first factor, it's going to give me a positive. Second one is going to give me another positive. So what's our end result? Negative, so it's going down. And the question asks us to find when is it increasing. It is increasing right here. So negative 1 to 3. D.
I'm so confused how you got like the 3 rows of like negative and positive.
I plugged in the negative 10 into the x's, plugged in the 0 into my x's, plugged in the 10 as well. We don't need a specific number. All you need to know is it a positive or a negative. So when you multiply 3 negatives, we get a negative answer. When you multiply 2 negatives, you get a positive answer. And when you multiply 1 negative, your negative is your final answer. Okay? All right, let's go on to number 6. What rule are we going to use on number 6? Could we use maybe a product rule? Quotient rule? Yep. But there's a better way. I can rewrite this because there's only one variable x. We can rewrite this as the following. Let's write it as y is equal to negative 5 times x minus 2 to the negative 1. Then do I have to use quotient rule on this one? We can use just the normal rule for the deriving. So let's write out. We are looking for concave up or down in this case. For concavity, how many derivatives do I need to take? 2. So we have double derivative is going to tell us when it's concave up or down. So let's write out our y prime. What do I do with the powers? Multiply them. You keep the inside as it is. One less of that power is negative 2. Now, when I multiply using the chain rule, is that going to affect the final answer?
Yes.
The times 1?
Yeah.
Would that change anything? No. So now let's write out our second derivative. When I multiply the power and the coefficient, what do I get? Negative 10. Then I have the inside as it is, 1 less. And again, the chain rule, times 1 will not be affected, so let's leave it just like that. And the way I should really write out is negative 10 all over, x minus 2 to the third. So we're looking for when f double prime is 0 or f double prime is undefined. And we know function is undefined when your denominator is equal to what? What can you never divide it by? 0. So we know x equals 2 is going to make it undefined. Okay, let's make our chart. And we're only looking at it from 2. So we have f double prime, and then we have the function. And we want to test out 2 points. What points should we test out?
0 and 6.
0 and 6. So let's see about plugging this one in. My top is already a negative. The bottom one, we have to actually plug in and cube it. So if I plug in a 0 in here, I'm going to be left with negative 2. What is negative 2 to the power of 3? It's another negative. Then I have negative times another negative. It's going to give me a positive. So that means it is concave up. Okay, let's plug in the 6 then. My top is negative no matter what. When I plug in the 6 into x minus 2 and I cube it, that's going to be resulting a positive, right? So negative times or divided by a positive, it's going to give me a negative. So this is concave down. And the question asked us, when is it concave down?
Whenever it's greater than 2.
There you go.